We're going to talk a little bit about frac chemistry this morning. Fracturing fluids work by transporting sand down in the ground. In order to make that work, we've got to thicken up, viscosify the water so it'll carry the sand down into the formation.
Whoa, then you're making this too hard. We can do this very simply if you just let us break it down a little bit to more common chemistries.
Well, okay, my man Val here is going to tell you how we make frac fluids.
Thanks, Jeff. Because there's a lot of questions about hydraulic fracturing, I want to take some time today and go through some basic chemistry and show you what we can do with just things around the house or a lot of homes or in grocery stores that will change up chemistry similar to what we do out in the field. To help me do this today, I got another QGC employee. Zoe, how are you today? First thing we need is water. Can you get me about a liter of water? And we're going to mix it up in a bowl. Water is the biggest component of what we do in hydraulic fracturing. We needed a fluid to carry material down into the wellbore. All right, so water in itself is not enough. We got to do something. We got to change this water so it actually can move things around. So what we're going to do is we're going to add a little bit of flour. In this case, can you grab me some bean flour over there? So water is a viscosity of 1, right? And I got to change that viscosity or that thickness to make it so it can actually hold sand and move it down through the steel plumbing that we use out in the field. What we're going to do is we're going to carefully add in about 3 grams of guar bean flour. And what we're going to do is we're going to just mix that in. So this starch, what it does, it gets into the water and it starts to hydrate. What happens is it starts to grab onto that water and starts to puff up and grow. In the industry, we actually consider water a very high friction fluid because we have to pump it through pipe. Yeah. And when we pump it through the steel pipe, just like the steel plumbing for the faucets, it creates a lot of friction. And we're pumping it at a fast speed and it wants to push back, just like if you have a parachute attached to you, and it slows you right down. So what we have to do is try to make it slippery so it can move things a little bit better. So this takes a few minutes to happen. So we're just going to set this off to the side while it does that. Besides the guar bean, we also have to put something in the fluid that actually will control the clays. Now the clays are actually just naturally in the rocks in the ground, and those kind of hold up against and they make it very much an impermeable layer or a very difficult layer for that water to flow through. So what we'll do is I'm going to get 2 cups. Can you grab me 2 cups and put about the same amount of water in each? I brought with me some clay. This is the same clay that a lot of girls put and use for foundations or blushes. Now we have 2 waters here. It's the exact same water, right? We're gonna have to change one of these, but we're gonna start off with this one here. There we go. So did this go in? No, it kind of lumped up, and if you can see, it's kind of mushed up. Yeah. If I do this down in the rocks below the ground, what happens is that kind of goos up and gloms up into the formation. And so in this case, the coal starting to get glued up and stuck. And the whole thing is it does the exact opposite of what I want to do when I do hydraulic fracturing. What I really want to do is get this so it's not reacted. So we're going to have to change this. And I think I have some salt over there, and we're going to use that, and we're going to change this water. 1, 2, perfect. There you go, 3. We'll mix that up. So all we're doing is we're taking that salt and letting it dissolve, getting right into the solution. Now we're going to take the same clay, give that a stir. Is it reacting differently?
It is, yeah.
Yeah, and so it's going right in. So what happens is that the salt ions are battling against the magnetism of the clay, and so the clay can't pull itself into it. When we're doing hydraulic fracturing, we're pushing on the rocks, and when we push, we blow open the rocks, or those cracks that are there, and we push the fluid in there, right? If that fluid's going to react with the clays that are naturally occurring in that rock formation, what happens is they puff up, and they'll actually cause a seal in the cracks that we're trying to create to let that gas flow out of. And that's not something we want to do. Now, this has been sitting for a few minutes, and as it's been sitting, I want you to feel it and tell me what it feels like.
Greasy.
Greasy. It's very slippery, right? This is what we're talking about, how we change it from being a high friction fluid, which is water, which is kind of rough when you rub it, to what this is now, where it's kind of slippery a bit. And we need that little bit of smoothness so we don't have to pump as hard. So I use less equipment on surface, and I have less noise because I don't have to push as hard. And when you push hard with an engine, it has to rev up pretty high. But this in itself is not what we pump down the formation. We have to add something else. We have water and sand. Those are probably the 2 biggest things. And I think we brought some sand over there. So we're going to get some sand and we're going to add it into this mix. And we're also going to need 1 more liter of water, and we'll do a comparison between the 2. And the sand, what it does is it gets in between those spaces and holds it open so it doesn't close on itself. You start putting a few grains of sand in there, and it gives it just enough space to let the gas or oil to flow through. In this case, what we're going to do is we're going to add about a half a cup of sand into this bowl, the other bowl. So I'm going to stir this one, and you can start to see I have to stir fairly fast to get that sand to stay in suspension. When we go over here, if you watch, it doesn't take much and I start to suspend the sand. All right, about the same amount of energy I was doing here, and it's already come up and it's kind of now suspended a bit. If you also feel the fluid's changed, put your fingers in there.
Is it safe?
Is it safe? Well, what's in there?
Water, sand, and water.
Yeah, and it's slippery. Can you grab the borax, and we're gonna mix it in with the solution and create it so it actually starts to tie up. What is borax?
It's a stain remover and disinfectant used for laundry and cleaning walls and bathrooms.
Okay, so what we're gonna do is we're gonna add some of this chemical in with a solution of water, and we're gonna mix it in, we're gonna add it to this. We only need about, a few grams. We'll add that in there. We'll give that a good stir. Now, do you wanna do the mixing or do you wanna do the adding?
The mixing.
You're gonna do the mixing, sounds good. So get your hand right in there. So you tell me when you start to feel this change on you. Most people, when they're using borax at home, they're using a lot more of a higher concentration than we would use when we actually have our fluid made up in the field. You're gonna lift that your hand out and see if that's, ooh, isn't that nasty?
It's pretty gross.
And what this borax is doing, it's a transitional metal, and it's tying those starches together, and it holds the sand in suspension. So it's easier to pump into the formation, and this is usually what scares people because they think we've done something really nasty. But all we did is starch and then tied it together.
But that's reversible.
Yes, it has to be reversible. Why it has to be reversible is I can't leave this in the formation because this would actually block off the gas from coming out. We'll get that lemon juice, and this is what we're gonna use to create a pH adjustment, and it's gonna create those bonds to break. Give it a good shot in there. Oh, there we go. So you can see almost instantaneously this starts to break down. And this is what we want to have in the ground, and those rocks that we just caused those cracks through that fluid. Just by shifting that pH, we went from something that was holding itself up to something that just flows nice and cleanly through. The fluid can flow right back up the steel plumbing out to the surface and leave that sand behind in the formation to hold those cracks open. So this is a good basic overview of what hydraulic fracturing fluids are. We started off with the water, added a little bit of a starch to get that viscosity and slipperiness that we need. We added another chemical, a boron ion, caused it to tie up and lock up so we could actually easily pump it. And then we broke it. And in between the time, we also added something to give us a bit of a clay control so we're not reacting on the things inside the rock layers that we're working on. So this, overall, is what hydraulic fracturing fluids are. Well, thanks very much, Zoe.
Thank you, Val.
You're welcome. So this is a good basic overview of what hydraulic fracturing fluids are. It's not exact. Chemistry will change based on the formation of the rocks that we're working on, the water that we're dealing with, and the equipment that we have on location. Every time we go out to do a hydraulic fracturing job, we try to ensure that the science and the percentages and the concentrations are fit for purpose for that well in that area. This is the science that QGC is working together today to make sure that we're doing the best job we can.
The basic idea of hydraulic fracture stimulation is actually quite simple. We create cracks under the ground and create an enhanced pathway for fluid to flow to the well. There are two reasons why we frack wells. The first reason is it increases the production rate. Secondly, it allows us to put wells in locations that otherwise we would not. All of the chemicals that we use are disclosed. If anyone is interested in them, they can find them on our QGC website. Those chemicals have been approved for this use by the appropriate regulatory agencies. We use the minimum loading of chemicals that will allow us to do the job that we are intending to do. And we choose chemicals that are as green and as safe as we possibly can.